This video is going to go over how to evaluate inverse trig functions. So one thing that's important is if you have a trig function, we need to be able to undo that trig function so that we can find things like when is the sine of theta equal to, let's say, like root 3 over 2. Well, that might happen on the sine graph because it's periodic multiple times. But when I want an inverse function, I need one input to have one output. And what that means for the inverse sine of root 3 over 2, when I switch those equal to theta, is that I'm plugging in one input into this inverse function and getting multiple theta outputs, which is an issue. And so there's some wording here about that from the textbook online. But basically what we are going to end up doing is we're going to say, well, let's only look at sine from negative pi over 2 to pi over 2. And so when I take the inverse of that function for inverse sine, flipping that over x equals y, I end up getting that my inverse sine function has a domain from -1 to 1 and a range from negative pi over 2 to pi over 2. If you want to think about this, if you're more a unit circle thinker, then that means I'm defining the unit circle outputs for sine inverse to only be in quadrants 1 and 4. So if I need to find, like, where is sine theta equal to -1/2, it is true on the sine graph that this would happen multiple times. But if I say find the inverse sine of 1/2 equal to theta, so that this is a function and it only happens once, I'm going to look at plugging in negative 1/2. I'm going to look at plugging in -1/2 and being like, what is that theta value? Or you could also use the unit circle and know that sine is negative down here. And so, like, what angle gives you that sine output? So a couple different ways you can think about it in order to figure out what that theta value would be. Cosine, we are going to restrict from 0 to pi instead. When you do your cosine graph, if we were to flip this whole thing over y equals x, and then try to do it on the same domain that we did for sine, you wouldn't end up getting a function here. So we can't do the same thing that we do for sine for cosine. Instead, what we're going to do is we're going to look at just this piece from 0 to pi and flip that. So 0 to pi now becomes my, becomes my y. So I go from 0 to pi, and then from 1 to -1 when I flip that over the x-axis. All right, and then we also have tangent. This is the inverse cosine. We also have tangent. When we flip tangent, I don't have to worry about any type of domain restrictions as long as I'm looking at just this domain restriction normally. And so when I flip tangent, the inverse tangent function ends up looking like this. And it has two horizontal asymptotes, y equals negative pi over 2 and y equals positive pi over 2. All right, again, here's some more wording on everything I just talked about. I personally like to rewrite my question that I'm going to show you here kind of like in this form. So if I need to find the sine, inverse sine of 1/2, then I'm saying like what angle of theta gives me 1/2. Well, on my unit circle, right, that happens multiple times as you go around and around. On my rectangular coordinate graph, that also happens multiple times as we go round and round. But that's not necessarily what I want to find here, because then inverse sine has multiple outputs for that one input. Instead, I just want to know the one value in here that would be true. All right, if sine is 1/2, 1/2, then this must be square root of 3, meaning that theta must be pi over 6. All right, let's look at B. Sine of theta equal to negative root 2 over 2. Well, sine being negative means that I'm going to be looking here. Root 2 over 2 means that I'm going to say that theta is equal to negative pi over 4. Now, in this case, I do use the negatives and the positives because I'm only defined in quadrant 1 and quadrant 4 from this initial angle. So I'm going to use negative pi over 4 in that case. All right, let's look here. Cosine of theta equal to negative root 3 over 2. All right, inverse cosine, we're going to look from 0 to pi, and then cosine's negative over here, and I need adjacent to be root 3. All right, so that's going to be 5 pi over 6. All right, tangent of theta equal to, inverse tangent of theta equal to 1. So when is tangent theta equal to 1? Well, that happens at the pi over 4 piece. Now you can, I know I said there was no like domain restrictions. We are looking at the tangent function, right? Only from negative pi over 2 to pi over 2. So I am only looking at like this part of my unit circle in quadrants 1 and 4.